Hi, this is Anita from RMD Engineering College. Let's see a mood model. Here there is an example. So this is the state diagram and state table. So from the state table we can get the state diagram, and from the state diagram we can obtain the state table. So both the ways are possible. So first let's see about the state table. So here the present state is 0 0 0 1 1 1 1 0. So the next state, if the table is already given now, they would give the values till this, that is present state. Next state, where the x0 and x equal to 1 are the inputs. So this is the present state. With the input x is equal to 0, it goes to this state. When present state is 0 0, when the input is 1, it goes to 0 1 state. Likewise, all the combinations they have given. Then we should find out the flip-flops inputs. Here the taken flip-flop is D flip-flop. So for D flip-flop, we have to mention the excitation table. That is present state, next state combination. What is the value of D? When the present state is 0, next state is 0, then D value will be 0. Likewise, the combination of 0, 1, it will have 1. 1, 0, it is 0. Present state is 1, next state is 1, then D value will be 1. So in the Moore model, what is the characteristics? The sequential machine whose output depends only on its present state is called as Moore machine. Here the output will depend, whose output will depend only on the present state. So it can be related by this means also, that is the next state is a function of present state and input. The behavior of the Moore machine is given by these statements. So from this we can obtain the state diagram. That is, we know that from this state, when input is 0, it goes to this state. First we have to draw the four different states. Maybe this is 0 0 0 1 1 0 1 1. So when it is in 0 0 state, when x is equal to 0, it goes to the same state. When x is equal to 0, it goes to the same state. So that is, I have written for this combination. So for the next two combination, 0 0, x equal to 1, it goes to 0 1. That is, for x is equal to 1, it goes to 0 1. Likewise, we can repeat the operation for all the other states. We will obtain the state diagram. From the state table which is given up to this, we can obtain the state diagram, or from the state diagram we can obtain the table up to this value. Then about the flip-flop inputs. So here we are taking the D flip-flop. So again we are stating the x equal to 0 here, x equal to 1 here. So for this combination, let's take only the A part alone from the present state and the next state. Present state is 0 and the next state is 0. Come to the table here, 0 0, D is equal to 0. Hence we have got D equal to 0. This all goes for A value, DA. Okay, next we can see the combination A equal to 0 in the present state, A equal to 1 in the next state. For 0 1, we are having the D value 1. That is this value. Likewise, the table is filled up by means of taking the present state and next state of the A values. So this table and this table of dA is filled with respect to x equal to 0, and for x equal to 1 we have to take the combination of present state and next state here. So we have to fill this. So likewise for dB. So we have to take the B value in the present state, B value when x equal to 0 in the next state, and fill the DB value here. DB value here. DB value in this part we are filling it. Then we are taking the present state B value, next state B value when x equal to 1 is taken to fill this value, because here x equal to 1 and we have to take the combination of present state and next state. So we will fill this table, and by using the excitation table of D flip-flop. After that, from the tabular column we can know where and all, for which combination and all dA equal to 1. By filling it in the K map, we will be able to obtain the dA equation. dA equal to, so here we have got 3 1, so it is actually individually grouped. So we are having the dA equation obtained in this manner. Likewise dB, from the table where and all dB equal to 1, those combinations are found out and the K map is filled, and then the grouping is made like this. The grouping is made and dB value, dB equation is obtained. Thus we have obtained dA and dB equation, which are the input equations of the flip-flops. These are the input equations of flip-flop. Input of flip-flop, D flip-flop. dA is one flip-flop and dB is another flip-flop. Here we have drawn the dA flip-flop and dB flip-flop. Here we have the clock pulse which is given simultaneously to both the flip-flops. That denotes this is a synchronous circuit, and here dA input equation is drawn, is connected by means of the digital circuit. Likewise dB equation is found out and its connection is given as such. Thus finishing up the design of the flip-flop inputs. So here we have got the dA and dB. Thus we have implemented the circuit.